So yeah, everyone ready with tassel with that file?
Yes, sir.
Yeah, madam. Still downloading?
Yes, sir, still downloading. Hopefully tomorrow I can do that.
Okay, just see, sir.
Okay.
So see, this is actually that original file. So if you can see on the left side, number of taxa are 244. So this 244 means these are the total number of accessions. Like you can see here, this IS numbers, and total number of sites are 557,272. That is 5,57,272 markers. This file also belongs to the sorghum. So here you can see the chromosome-wise distribution of the markers. But likewise, in our earlier file, we deal with only 3,000 markers, as that was the filtered file. But this is unfiltered file. That's why here we can see lots of n. N means missing values. So first of all, we need to clear these missing values, and we need to clear the alleles or the markers. Those are having less than 5% of heterozygosity and less than 5% of variability. So this heterozygosity and variability is calculated across the 244 accessions. So on that basis, now we will do the filtering of that file. So here, the minimum allele frequency, we need to give 0.05, that is 5%. Minimum heterozygous proportion, 0.05, that is also 5%. Then here, if I click on OK, so see, this is your original file with 5.5 lakhs of markers. After filtering, your number of markers are 6,557. So, which markers are excluded or deleted? The markers with less than 5% of variability and the markers with less than 5% of heterozygosity. So these two criteria, those the markers, they are excluded. Now, next is we'll load the phenotypic data. The same data what I have shared as a part of assignment. So this is now this time. Last time we only saw single trait at a time, but now here see, there are multiple traits are there, 3, 6, 9, 12, 15, 16, 17. Yeah, almost 20 to 25 traits are there. So at a time now we will go. So then the next step, we will merge these two files. Then next step is we will go for the calculation of matrix. So then this matrix along with phenotypic and genotypic data.
Excuse me, sir. We are merging with the function of like intersect join.
Yeah.
Okay.
So this matrix along with phenotypic and genotypic data, we'll go for LMM, mixed linear model. So here we need to go for optimum level, and then we need to run it. Here, just we need to click on the filter, the output file based on p-value. So automatically you can see on the left hand side, analysis will start. As number of threads are more, so it will take some more time. Now we have reduced the number of markers, but still number of threads are quite more. So for all the threads, it will perform the mixed linear model association analysis. So at that time, you will get the QQ plot, Manhattan plot.
So, excuse me, sir, this file are raw files, so we have to remove the end that is showing like it's a missing
Yeah,
data.
so that's why I told, yeah, you need to go to filter,
Okay, sir.
then filter the genotype table sites.
Okay,
First
sir. So
option,
first we have to select the GBS data one file, and then we go to the filter
yeah,
and and then select filter genotype tables. Sorry.
by sites. First option only.
Okay, sir.
And give 0.05 in minimum allele frequency and minimum heterozygous proportion. So that will exclude all the markers which are having for less than 5% variability and less than 5% heterozygous proportion.
Sir, where is the merge option is there?
Sir, just after uh, like selecting the minimum heterozygosity, what we have to do again then?
Okay.
Then after that, sir, after that.
So this is your genotypic file. Okay.
Yes, sir.
This is your phenotypic file. Okay.
Yes.
Yeah. So in this genotypic file, here total number of markers are 5,57,272. So in this, if you can see, there are lots of missing values. And maybe there are lots of markers with less variability and less heterozygosity. So that markers we need to exclude. So generally for exclusion, there are two levels, just like in our field data at 5% and at 1%. So same concept we need to apply here. So minimum allele frequency refers to heterozygosity. So here we have mentioned 0.05%. That is 0.05. That is out of 100, 5. Then minimum heterozygous proportion, again we need to mention 0.05. Means there are two levels, 1% and 5%. So here we are preferring 5%. So after writing this, simply we need to click OK. So this will give us the filter file. No problem. Still this some missing values are there. Let it be. So then we need to select this filter file and phenotypic file. We need to go to the data tab. After that, intersect join option is there. 1, 2, 3, 4, 5. Sixth option in data tab. So if you will select it, ultimately it will give you the merge file that will contain GBS filter plus phenotypic data.
Sir, that
Okay.
phenotypic data, how we got?
Everything is on your mail.
Acha, okay, sir.
Each and every file, everything is on your mail. So then by selecting the GBS filter, we need to go for kinship matrix. After that, just select that merge file and kinship matrix. Go to analysis part and go for MLM. Here, select the optimum level and go for run. In next window, just select this filter output on p-value and click on OK. So after clicking on MLM, you need to do two things. First, you need to select the optimum option, and in second window, you need to click on the filter on p-value and simply click OK. This analysis will start.
Sir, after joining the extracted file, what we need to do?
Which file?
After, sir, merging the both files, what we need to do?
Just now I told. I will cancel it. No problem. So this is your merge file. Is it?
Yes, sir. Yes, sir.
Yeah. So this is your filter file.
Yes, sir.
Yes or no?
Yes, sir.
Then select this filter file, go to analysis, relatedness, then kinship, and simply click OK. So everyone, please let me know up to this. Up to this done. Yeah. So can I proceed?
Sir, phenotypic data file is yesterday you mailed, sir, that phenoblub 9 core started, sorted. That is the, sir.
Yeah. So can I proceed now?
Hello, sir.
Yes.
Yeah. Please, how do we handle the missing values? Can we impute it or we just use it like that?
So that's what I'm telling, sir, from last 25 minutes. That's what I'm waiting. Just give me a minute. Yeah. So please, everyone, see the screen. Don't do anything for 10 minutes. Wait. See the screen. Everyone, please, it's request. So this is your Tassel GUI. I have shared yesterday 2 files. These files I have shared yesterday. I hope the screen is visible. So we are working on these 2 files. Yeah, we are working on these 2 files, GBS and Pino Blocks Mini Core sorted 2015. So first thing, I will upload that genotypic data. Yeah. So this is the genotype file. So here total number of accessions are 244 and total number of markers are 5,57,272. Here if you can see, there are lots of missing values. And when you will extract the files with such a huge number of markers, so there may be the chances of markers with less variability and less heterozygosity across that particular specific population. So first we will try to filter out the file for missing values and the markers with low variability and low heterozygosity. So for that, what we need to do, just select this GBS, go to the filter option, select the first option only, sites. Then here you will see the number of options, but concentrate on this third and fifth option. That is third is site minimum allele frequency. So minimum allele frequency is the amount of variability per molecular diversity or variability. So here I will give threshold level of 5%. So below 5%, whatever the markers are there, I don't want. Then same in case of heterozygous proportion, below 5%, I don't want. So likewise, I have mentioned the threshold and then simply I will click OK. So from after that threshold, from 5.5 lakhs, we came to 6.5 thousand. Okay. So next step, I will upload the phenotypic data. So this is the phenotypic data. Almost 25 traits are there. So at a time we will go. So as it will take some more time, so I will show you how to draw the dendrogram from this. So just select this filter file, go to analysis, relatedness. Third option is create tree. So there are 2 options. As almost all of you are well aware regarding D-square statistics. There are different statistical methods, that is neighbor joining dendrogram, UPGMA dendrogram, K-means clustering, hierarchical clustering, H clustering. So here in this case, 2 types are there, neighbor joining and UPGMA. So generally we'll go for UPGMA. Just you need to select the clustering method and you need to click OK. So this is, we prepared a tree from the data. From the GBS data, this is the tree. Now we need to prepare the dendrogram. So we need to select this tree, go to result, and then Archaeopteryx tree. So this is your dendrogram. You can change the shape. Is it visible?
Yes, sir.
Sir.
So now if you want to change the shape, here you can make it like this. Then you can make it like this. You can change the shapes like this, triangular. So it will give the distribution of genotypes in cluster based on your molecular data. If you will zoom it, all your genotypes. So this is the dendrogram. Yeah. Then firstly, we will come back. I will repeat it that again. So from this GPS filter, first go for kinship. Then if you are not interested to merge genotype phenotype files, no problem. With kinship, select the three files: GBS filter, phenotypic data, and kinship matrix. Go for analysis, association, MLM. Go for optimum level. Run. Next window, click on this filter output. Okay. So this analysis will start. Just start this analysis, then we will shift to RStudio. Let this run, it will take some time. Meanwhile, we will run that RMVP package. So just complete these steps in Tassel. So for tree analysis, you need to select the filter file. Then relatedness. You need to go for create tree. So after that, this type of file will come. After that, you need to go in result and then you need to select this option, Archaeopteryx tree.
Sir, which model we selected? Sir, that neighbor joining or sir, that one?
UPGMA.
Sir, after complete running MLM model, it is showing errors. Some.
Which files you selected?
Sir, merge file and centered GBS dataset.
Which merge file? Filtered or unfiltered?
Sir, filter plus phenotypic.
How many files you selected?
Sir, one merge file and centered
Show me
IBS
the screen-
dataset.
Share me the screenshot of your whole Tassel window. whole window, not just error.
Sir, after analysis, sorted file came out, sir.
Which sorted file?
Sir, mini sorted file. Uh, Sir, MLM statistics for phenotypic blur, mini core sorted, and MLM effect for phenotypic blur, mini core
Your
sorted.
analysis completed.
Yes, sir.
So see, these are lots of files you will get, like
Yes, sir.
residuals. Then at last you will get the MLM statistics file. Then MLM effect, nothing will there. Then this MLM compression. Okay. So select this MLM statistics file. Go in result and click on click. What happened? Something is here. Wait. MLM. Some error is there in this. Let's just wait for 1 minute. I don't know what happened. Just try to draw the Manhattan with that statistic file. Again, if you have any difficulty, just you can see again I am doing. So yeah, for you it is working.
No, sir.
So just I am trying this weighted MLM. Try for weighted MLM with these three files.
Sir, you selected phenotypic blur and GBS filter. Sir, for Manhattan plot, then only you got that blues and phenotypic blur and phenotypic ANOVA, na, sir?
It will take time. If MLM is not coming, just try this weighted MLM or GLM. Then we'll go for that RStudio. What happened? So first simply go for GLM. That one option I wrongly clicked. That's why it was not coming. So simply for GLM, do one thing. Select this merge file. Go for analysis, association, GLM. Here, as it is, no need to change anything and click on OK. So after that, you will get these two files, stats and genotypes. So for stats, result Manhattan plot. So here as number of traits are there. So here you will get to see the option. If for any trait markers are not there, so it will not come. So likewise, just try this GLM. Yeah, Raj,
Yes, sir. Done, sir.
go for this GLM. For each and same with this stat file, you will get the QQ plot. If
Sir,
you
for
want
every,
combine for QQ plot, if you want combine, it will come for all traits
sir, for all
in
trade we have
one.
to go for GLM, na, sir.
Yeah. So if you want to delete some traits, then simply so one by one also you can get it. Next, from this filtering, analysis, diversity, LD. So here in LD type, there are three options: full matrix, sliding window, and side by all. So default it will be sliding window. So just we need to keep it as default and we need to run it. And from this result file, you will get the LD heat map. So which values? Yeah. Then in the same way, just go for the different models.
Excuse me, sir. Could you
Ah,
please
yes.
repeat for the just from starting from the filter file for LD?
For LD just this filter file we need to select, analysis, diversity, this LD option is there. This we need to select it. No need to change. Just you need to click on run. So this here at the bottom output file you will get. So directly result LD plot.
Okay, sir. Thank
Then you can go for the next model also.
So for LD, which file we have to select?
Genotype file, filter file.
Where we will save all these
Yeah,
generated files.
yeah, I will come on. Just see now this is, so see, this is the output of GLM. Okay. So if you want to save, just click on this result. First option table is there. Just you need to select it. Here you have one option. Either you can export as a CSV or you can export as a text file. So for Excel, we'll click on CSV. Just you need to enter the name of the file and you need to save it.
Okay, sir.
It is simple. In result option, that in the result table is there. So from here, you can save that file. And regarding graphs, so for graphs at the bottom, save option will be there. So just you can click it and you can select the file type like JPG, GIF, BMP, whatever is there. You can change the file type, you can type the name and you can say where you want.
Hello, sir.
Ah, yes.
Please, what is the difference between MLM and the weighted MLM, and which one is the most reliable?
So actually for association mapping, we will prefer farm CPU. So generally Tassel will not prefer for association mapping, but as it is one of the options, so that's why I am showing to you. So nowadays, this general linear model, mixed linear model, then this mixed linear multi that model MLMM, these are not preferred. Generally, we will go for Palm CPU, Blink, And one more model we will see, that RMBP. Just now today I shared that script. So this generally out of these three models, we will generally will use. So the reason is simple. Now see, now if you can see the representation quality. So this is the representation. You have seen the representation for farm CPU. Now you will see the representation through RMBP. So that representation qualities of those models
Sir,
are improved.
sir, can we save the filtered tassel file in HMP text format?
Yeah. So see, this is your filter file. Is it? So now, if you want to run the Jivas by using this file in app, okay, so simply select the file first, go to the file. Here, third option is there, save as. So, this type of window will come, right? So, after that, click on the browse, go to your respective folder where you want to save this file. Now, I want to save this here. Then I will give some name. Then I will click on save. Then here format is there. So here we need to click on HapMap and then simply OK. So if I see here you will get the file. So this is our filtered file. So likewise, you can save the filtered file from Tassel. And another thing, if you want to convert this genotypic file into numerical format. Yeah, anyone remember? I have told last week from where we can convert this file into numerical in Tassel. Yeah, anyone? Okay, so simply you need to select this, go to data, just scroll it down. Here you will get the option numerical genotype. So just simply click on that and click OK. So the same filter file you will get in numerical format. Just you can cross check for the numbers. For 0, what is the genotype? 1 is what? 0.5 is what? So just you can cross check it.
Sir, R is running on numerical file, right?
No, we ran R through this normal AppMap file also. It
Sir,
will
but
run on both.
in beginning of the models, it was showing that converting to the numerical files in R.
But we ran, we got output files, people are submitting assignments. It is not mandatory that you need only numerical file. You can do, but it is not. Just now I will show that RMVP model with this normal file. No problem. Result will be same. You can convert, no problem. Numerical file we need, strictly we need for that ICI mapping, QTL mapping.
Okay, sir.
There we need compulsory numerical file. But here we can run. So then you can go for PCA. Likewise, plots will come if you want to change it. So you can change. Likewise, plots will be there. In chart option, from chart option, you can draw the charts. For trades also, across trades also, so no problem. So now we'll use this same file. Now just open this file. This what I have shared you RMBP JavaScript. Open it with Notepad. And install this RMBP package in R. Install that RMBP package and run the library. As I have already installed, so I will run the library. You can install directly command line, or you can go through the tools option. So let me know after completion of your installation. Yes. We need to install this package. If it is not installing with this line, so just go for this dev tools. So here you have three options. First one is this highlighted. Second option is this one. Third option is tools.
Yes, sir. I install this package.
So then run the library. So now in this, we'll use the filtered file we used before vacation. Because just we will complete it, we will show it, then we will run with this all 25 characters. First we'll run for single thread. So we will run this small file first, that 3042 markers file and that phenotypic data of single thread. So for that, first set the working directory. As I have said this because these two files are there with me in this same folder. This one and this one. So for this RMVP, we are going to use the mark genotypic data of 3042 markers, old file, not the current one. Okay, so for this RMVP, we'll use old genotypic data file. So this is our MVP is a package. So that is, it is based on mixed model association analysis. But in this addition is, it will go for calculation of blocks. It is based on blocks. And in addition, it will give the density of markers on each and every chromosome. Yeah.
Excuse me, sir. Sir, which file we are using for this?
Old one, just the used before vacation. 3042 markers. Earlier one file. MDP genotypes, MDP traits. So those two files save in one folder and set the working directory. And then just start it. If you have changed the file name, just you need to edit here. Wherever the file names are there, you need to edit it. Then whatever here, we'll convert the data into this MVP format. So MVP is memory efficient visualization. So after converting, here you will get at the last MVP data preparation accomplished successfully. Then the next step, at a time we will import it and we will run the analysis. So up to this, you will get the some files. Yeah, if you can see, just see this. This is the circular Manhattan plot. Through this RMVP package for all three models, that is GLM, MLM, and WAM CPU. The addition is, there is the addition. I think this one. No. Yeah, this is the distribution of thread. As it is single, so this is the distribution, frequency distribution graph you will get. Then yeah. So see here, this is the addition. So across 10 chromosomes, it will give the density of markers, density of SNP markers throughout this region. So this marker density graph, this RMVP package will give. Then same QQ plot, but somewhat more colorful. You can see all three QQ also.
No, sir.
Yes.
Yeah, please, for the density plot. So, which of the chromosome has the highest marker density?
So see, here are the colors. So dark red color is the region having the highest markers. So according to this color, you need to decide the region and the chromosome. Gray color means no marker, then green, this color, this is changing, and here are the number of markers. So on the basis of this, you need to decide the chromosome and the region with more number of markers. So highest is dark red, more than 109. So the shades are changing, green, then somewhat yellow, and then red.
Excuse me, sir. In this diagram, it's showing like red has more marker, like more than 109 something. But in the graph, very few points for red. So what is the meaning?
Nothing. Meaning is simple. Whatever your data is there, on that data, this is the distribution of markers.
Okay, so these are the
That's,
distribution of marker on different chromosome.
yeah.
Okay.
Within this region is there 0 MB to 80 MB. So that region is there. So in that region, how these SNPs are distributed across the chromosomes, across the your location in 727 MB, 28 MB, 30 MB, 32 MB, whatever it may be. Yeah. So this is the
So in this
here.
analysis, we are getting graph for like farm CPU and other
All
analysis.
three models. All three models.
So it's a more advanced model for GWAS analysis.
So
Like
actually,
using-
first positive is just you can compare the representation. That is the first point.
okay, sir.
Yeah. So and then it offers the memory efficient. So if your data is large, if you want to analyze the large scale genomic data, then this RMVP package is preferable. So it will that means it will be easy for us in case of large genomic data to visualize what we have. Because as we have seen four different models, so this density, no one model will give density. So this on the basis of this density, you can represent like in my data chromosome wise, this region is having more markers, this region is having no markers. So likewise, you can conclude. So this is again one of the positive of this package. So then these
Hello,
are
sir.
the
That SNP distribution would be different for each genotype.
it is not across the genotype, it is across the chromosomes.
So this particular window you are showing, it is for single genotype.
Not genotype, not genotype. Whatever the genotypic data you have,
Okay,
your
sir.
HapMap file you have for 10 chromosomes, marker is 3042. Just this representation is showing across chromosome at which of the places, what is the distribution of your SNP markers, distribution of your 3000 markers, just it is shown.
Okay, sir.
Then here you can see the QQ plot for all three in one plot, 3-in-1 Manhattan also. Then all three QQ. Then the colorful individual Manhattan. And then this one. So if you will run for multi-threads, again this representation will be good. Yeah, so up to this, everyone reach. Complete up to this. So after running the Jivas with this RMVP, you can see again, if you will scroll down, there are two things. PCA as a covariate, and secondly, kinship as a covariate. So what is the meaning of covariate? So here in this step, we are considering principal component analysis first, and then second, we are considering the kinship. So means here we have data, we are accounting for variability in the data, we are setting PCA as a covariate. And secondly, we are setting kinship as a covariate. So what is, we have estimated kinship here. Here also now we are estimating kinship. What is this kinship matrix means what? Yeah, anyone? What is the meaning of kinship?
The correlation.
Yeah, it is relatedness between the genotypes. So here, just simply here, no need to edit it. This PCA as a covariate and kinship as a covariate, and at last we are considering both as a covariate. So again, these are the three steps. Just you can run it. You will get the same output. So these are in this RMVP. There are these four types. One is normal analysis, and this PCA covariate, kinship, and both PCA and kinship. So just now you can run the Jivas analysis with that 6,500 markers. As someone told me that it will take 6 hours. So now it will not take not take much time. Just you can try with both the softwares, that is RStudio and Tassel. And one more thing. Have you drawn the tree?
Yes, sir.
Yeah, so that Archaeopteryx tree is there.
Sorry, Prof, can you go back to the step where you were visualizing the tree?
Where?
The step where we were visualizing the tree.
Tree. Okay, okay. I will repeat it. Just give me a minute. So see, we have GBS filter file. Okay. So then simply go to analysis, relatedness. Their third option is there, create tree. So just click on that. Here you will get two options, neighbor joining and UPGMA. So here we'll select UPGMA. And then we'll click OK. So this tree is created. So after that, at last you will get one output tree GBS filter. So just select it, go to result. Second option is there Archaeopteryx tree. So just select it. So it will come like this. So here you can change the color, change the shape. So in file, you have the option to save it. You can export to PDF. You can export to
Excuse me,
PNG.
sir. How can we change
Hmm.
this in this tree in different shapes? Like you are making right now is circular. So how you
So
do
here type option is there.
oh, tree type? Okay, sir.
Beside help.
Hello, sir.
Yes.
Yeah, please. The data that we use in our studio, the RMVP. So is it the data that we save from Tazo or
No, earlier file.
maybe it was named the one that you shared?
Last week we used one small file. Marker 3000 markers file.
All right, I will check. Sorry, I missed the class, so that could be.
No problem. No problem.
Uh, uh.
Ajay, Dr. Sir.
Yeah, excuse me, sir. Sir, can you please send the link for tussle and structure? Actually, last
Yeah,
two
yeah,
class
yeah.
I was.
Okay. No problem. I will share on your personal WhatsApp.
Sure, sir. Sure. Thank you.
Please, from the diversity analysis, could you show how we can do population structure?
Yeah, for population structure, we need to go for structure software. That also we will cover.
All right, thank you.
Yeah, so just now go for this analysis in Tassel. First try in Tassel. Then go with Farms APU. Our normal coding. And then go for this RMVP package. Yeah, so any difficulty is there, just you can reach out to me.
Excuse me, sir. When we will use the
Ah.
structure, we have the structure software. So it is for the GWAS analysis or something else?
No, population structure.
Okay. So, okay, I don't know about this software, so I want to know like when we use
No
this.
problem, no problem. We'll cover that, no issue. So for SSR, I told earlier, you need to code that SSR like your SNP. Then only then you can generate the HapMap file. So otherwise, HapMap with SSR is not possible in normal code. So then better if you have SSR, go for QTL. So just try this. If any error will come, so just you can share with me. I will get back to you. No, I'm not sharing the screen. If you have anything, just you can text me. Okay. So everyone, please download the structure software from website. And tomorrow we'll one topic we'll start, that is genomic selection. Genomic selection or genomic prediction, that also we will see. Along with
Sir,
the
can you please just show how to download a structure file?
website is there, Stanford. I will share the link in group, no problem. WhatsApp.
Okay.
Excuse me, sir. Rajit here.
Ajay, Dr. Sir.
Actually, earlier also I have told, I don't know whether it is already covered or not. Just in our company or previous company, we have seen that multi-location trials, they didn't use replication more than 2 or 3. Whatever the degrees of freedom they don't want that it should be like 12 of that.
So that means augmented design you are saying, na?
not necessarily augmented, but that use something bluff, and you told me that eye bluff or blue, like that. So is this already covered?
No problem. Tomorrow we are going to calculate it.
Okay.
Yeah, no issue. Because whatever the phenotypic data we are seeing, these are not actually phenotypic data. What we are using for mapping, these are the blobs. So how to calculate that part also I need to cover, so that I will cover it.
Okay, sir. Thank you.
How to calculate the blobs from your raw phenotypic data.
Yes, sir.
So no problem. Okay. So tomorrow at same time 6:15. And in the meantime, if you will face any problem, just share me the screenshot. And please share the total screenshot, not just the error. If you will share the total screenshot, I can get back to you easily. Okay. Thank you. And regarding your videos, I will update you within give me 1 hour. I will update you.
Okay, sir. Thank you.
Okay.
Thank you, sir.
Thank you, sir.
Yeah. Thank you very much.